Hello, welcome back to part 4 of our forces conversation in physics. So this time we're going to discuss what is the idea of weight. We talk about weight all the time, but weight, and as we know it, is actually caused by what? By a force of gravity, right? So it's the force of gravity that's acting on our mass. So our weight is actually the force of gravity that's pulling on our particular mass. So if you have more mass, then gravity, of course, pulls on you more, and it creates more force. But what about that? Is there a way to change that? So let's think of a little scenario. So let's say, here, we'll draw these in a different color here. So let's say we have two brilliant scientists. Let's say they got to be brilliant. Oh, that guy's got a big, strong, sorry. This guy's got seriously strong legs. He must be a runner. So yeah, he's a runner. His name is David. He's not only a runner, he's brilliant, a scientist. And he's got a buddy named Enoch who is also brilliant. And the two of them were thinking, we want to mess around. Let's change our weight. So let's build a contraption that changes our weight. And so I don't want to weigh what I weigh anymore. I just want to be brilliant and do something. And so here's what they do. They decide that they're going to build a box, right? And this box is kind of like an elevator, all right? So let's say that they first build this box, and they put a bunny rabbit in it to test it out. And here's what they do. They send this box, and they make this box really, really amazing because they're brilliant. And they have their bunny rabbit in it. Oh, it's got to have bunny rabbit ears. And so then, it kind of looks like a mouse. Oh well, that's a rabbit. And so what they do is they take this elevator and they have it screaming up. And they set it at the highest speed just because, they're scientists and they want to know what in the world is going to happen to their little friend named Fluffy, the bunny, right? And so Fluffy's in there. And so Fluffy gets in there, and so when this thing accelerates up, what's happening? Well, you have gravity all acting on Fluffy's mass, right? But you also are going to have this acceleration up, right, times Fluffy's mass. So let's say that, they have gravity, but they also accelerate this up at, 350 meters per second because they built this amazing... And actually, this elevator that they built can go all the way to the moon, right? And so they accelerate Fluffy up. So you can imagine the weight here. What's the weight? Well, let's say that Fluffy weighs 3 kilograms, right? So we've got 3 kilograms times 9.8. All right, so what does that equal? So 9.8 times 3 is going to give us 29.4 newtons, right? So that's Fluffy's weight plus 350 times Fluffy's weight. So 350 times 3. Because we accelerated it up at another rate on top of that of 350 times 3. So that's going to add 1,050 newtons. And so, what happens is Fluffy is totally squished and crushed under the massive G-force of this amazing elevator. So when they open it up, they find a little bit of fur and a flattened Fluffy, and they say, oh, that was bad. Let's go hide this in the backyard so Mom doesn't see. So anyways, they get rid of that. And so here's the concept right here. When you're going up in an elevator, you have your gravity, or your mass, times the gravity that's already acting on you, plus whatever that elevator is accelerating up times your mass. So you actually, if you were to go and stand on a scale in there, you would actually find that you weigh more, right? You weigh more when you're going up because you have another force. And so this is what we call apparent weight. And apparent weight is the weight caused by all of the forces acting on you. And so in this case, you have the force of gravity and you have the force of the acceleration of the elevator pulling you up. So you will weigh more. Now, on the other hand, when you go down, right, and they built this elevator and they started experimenting with it, and what they wanted to do is they wanted to be able to set it so when they went down, and if you're as brilliant as Enoch and David, what you could do, and this is what they did, when this elevator is going down, you could get it, right, so that the elevator is able to accelerate down at a fast enough rate that you basically have zero weight. So zero weight, or the idea is called weightlessness, right? And weightlessness is what the astronauts are experiencing when they're going through space. There's actually plenty of gravity up there where they're at, but they're actually falling around the Earth at a rate so that they can float around in that spaceship. So let's say that David and Enoch wanted to figure out then what acceleration they needed in order to experience weightlessness. So let's say that David said, okay, I've got these amazing running legs, so I'm a little bit heavier. So he looked at his weight, and he was 78 kilograms. So David weighed 78 kilograms. So that times 9.8. So 78 kilograms, he figured, was times 9.8. Gave him a total of 764.4 newtons, right? And so that's the force of gravity on him, right? So then what he wanted to do was, all he had to do was he had to accelerate down at a acceleration that was just right to be able to take that down to zero, right? And so when you're going down in the elevator, it's going to be subtracting your weight, or the acceleration down, times your mass. So all he had to do was get that thing to accelerate exactly down at 9.8 meters per second squared, and then they were floating around. So they're playing with this, and they're playing with this, and they say, hey, let's go up to the moon, and then see what happens. So when they get up to the moon, what changes? Well, we figured out that it was 764.4 newtons of force on David here on the earth, and then as long as he went down on that, and of course Enoch was in it too, but Enoch, he was pushing the buttons, and you know what he did? He's like pushing the buttons, and he went up and down, and so David's like, bam, 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 and he gets out and smacks him in the face. Ow, stop it. So anyways, they had that little spat, but then they decided, hey, let's both go to the moon. So they go to the moon, and on the moon, what would be the difference? And because they had to change this elevator, they found that as they got up to the moon, the things were a little bit different. In fact, the acceleration of gravity on the moon is only 1.0 meters per second squared. Okay, so they were already lighter. So all they had to do was change the speed of their elevator when they got to the moon. So what was David's force on what was David's apparent weight while he was on the moon? Well, the force of gravity on David on the moon is just going to equal his weight, which is 78 kilograms times 1.60. And so that's going to equal what? 78 times 1.60 equals 124 newtons, 124.8 newtons. So as you can see, wherever you are, your apparent weight is going to equal all of the forces acting on you. So if you're in something that has an acceleration that is going up against gravity, you're going to be adding gravity plus the acceleration times your mass. And if you're going down with gravity, you've got it's subtracting from gravity. So know your directions and know your situation. All right, one other concept real quick that I'd like to go over in this video is the idea of drag force and terminal velocity. So drag force. So this is a force that could be acting on you when you're falling, okay? So if you're falling through the air, right, there's going to be the forces of the air molecules hitting you as well. And at some point, because those forces, the faster you go, they're going to become greater and greater and greater. And so as your velocity increases, the drag force increases. And so drag force is the force from fluids on an object. And when you jump into the water, you experience a lot more drag force than you do as going through the air. So you reach a terminal velocity a lot quicker underwater than you do in the air. And so what's terminal velocity? I said that. So terminal velocity is the speed that you would reach that would cause your force acting on you to be equal to the force of gravity. So essentially, what happens is that you stop speeding up, okay? So this is pushing on you so that no longer does gravity speed you up because the force here equals the force here. So you have no net forces acting on you. So that's what terminal velocity is. So essentially, the more mass you have, the higher your terminal velocity, right? Just a quick little thing on those two things. So in the next video, what we're going to do is we're going to look at some drag force and terminal velocity sort of issues and problems, and kind of go from there.